anyway, the fact is, in 1997, there was a press conference on the White House lawn, and Bill Clinton was there. And you can actually see it in the movie Contact with past guest on my show, at least Ann Druyan, who would make a great guest for you, the widow of the late, great Carl Sagan. And she co-wrote the book Contact, on which the movie is based. And in that, they take a scene from this, so that was 1997, 1998. They took a scene from the late 1996, when there was a declared announcement from a discovery of meteorite relics in Antarctica of possible microbial respiratory byproducts or something like that.
Good afternoon. I'm glad to be joined by my Science and Technology Advisor, Dr. Jack Gibbons, to make a few comments about today's announcement by NASA. More than 4 billion years ago, this piece of rock was formed as a part of the original crust of Mars. After billions of years, it broke from the surface and began a 16 million year journey through space that would end here on Earth. It arrived in a meteor shower 13,000 years ago. And in 1984, an American scientist on an annual U.S. government mission to search for meteors on Antarctica picked it up and took it to be studied. Appropriately, it was the first rock to be picked up that year, rock number 84001. Today, rock 84001 speaks to us across all those billions of years and millions of miles. It speaks of the possibility of life. If this discovery is confirmed, it will surely be one of the most stunning insights into our universe that science has ever uncovered.
Now, that was actually, vetted by NASA and had to be broadcast from the White House lawn. It was actually, some articles are published in Science and so forth, peer-reviewed and everything. And that showed that there are meteorite activity that can come from Mars and land on the Earth at one thing. And then that life could persist potentially. And by the way, that's never been retracted formally. I mean, it's never been like there's been that we were wrong. It's just ambiguous. It hasn't been confirmed or refuted.
It's pretty wrong. It's pretty wrong, by the way.
Be that as it may,
we know that it's wrong.
Yeah. The fact occurs to me that given that there is life on Earth, and given that it arose a few 100 million years after the origin of the Earth, we've had 4 billion years for these little chunks of rocks, which, by the way, you can win if you're one of the next 100 subscribers to my mailing list, briankeating.com. I send out meteorites to people in America. All I can afford is to send out American meteorites through the U.S. Postal Service, but Gravity will deliver it once you get it. Given that we haven't found life on Mars or on any other evidence of life on Mars, is there some amount of Bayesian prior reasoning that we can then diminish the probability of life being present throughout the universe? In other words, we often hear that as soon as life came on Earth, which, we don't know how that came about, maybe it's panspermia, maybe it's not, but kind of the fact that reverse panspermia can occur. We can kick tardigrades off of a chunk of the Grand Canyon and can go into space. How come, can we use that to reason that life is actually not that abundant as many people think, and certainly not advanced technological life? Or am I, is this not an appropriate way to view the problem?
Well, I don't think we can go quite that far, but the fact that we do not see abundant, very obvious life on Mars or other bodies in the solar system, all else being equal, lowers our probability of life being ubiquitous in the universe. On the other hand, if your theory that you're trying to update is 1% of Earth-sized planets have life on them, then the existence of no life on Mars doesn't change your prior probability very much at all. And 1% of the planets out there would still be billions of places to have life out there in the universe. So I draw a big distinction between life and anything that you think of as advanced intelligent life, right? That's a very, very different question.
Absolutely.
I think that there are good Bayesian reasons to think that there are not that many advanced civilizations in our galaxy. That is something that we could have observed very, very easily, and we haven't.
Yeah.
And every time I say that, the UFO people come on and say, wait until this guy is shown up in 6 months when the new report is released. But this has been going on for 10 years, and the new report has never really shown me up. So I'm pretty confident about that.
Right.
But that's very different than saying, is there simple unicellular life out there? That could be everywhere. That could be on Europa. That could be there could be even multicellular life on Europa. We don't know, in the oceans of Europa. But we'll have to go look. The best Bayesian does not get very far when you only have 2 or 3 data points. So we need to collect a lot more data. And the exciting thing is we're going to do it. That's kind of awesome. We're going to be updating our priors in a substantial way.
Yeah. Yeah. And I think, if nothing else, that discovery in the late 1996 demonstrates that, people think, oh, it would change humanity forever. The discovery even of a microbe of slime mold on Proxima Centauri b would change forever. We'd have this community. I say, no, it wouldn't be. And there's proof that it would, because no one, like 99% of the people that even heard about this in 1996 probably still think it was accurate or it could be true. And I don't think we've had this, great kumbaya moment across humanity.